In this unit, we will look at different types of data. We will also look at various ways in which data can be summarized. This will usually involve drawing a diagram which enables us to appreciate the qualities of the data more clearly. For example, drawing a box plot or histogram. In order to do this, we shall use various data samples. Our first data sample consists of the number of claims arising under 200 motor insurance policies. Let us suppose that of these 200 policies, 152 experience no claims in the year, 28 policies have 1 claim each, 14 have 2 claims each, and 6 have 3 claims each. How can we summarize this data in a helpful way? We will start by drawing a bar chart for the data. A bar chart for these data will look like this. The height of each bar represents the number of policies having the given number of claims. Note that this sample is a sample of discrete data. The number of claims per policy can only be an integer, 0, 1, 2, 3, and so on. Now let's look at some continuous data. Here is a small sample of claim amounts taken from a portfolio of contents insurance policies. There are 10 claim amounts ranging in size from 254 up to 302. Note that these numbers are monetary amounts. Because they could theoretically take any value, we regard these as being continuous data, although the figures given here are all integers. Let's assume that these amounts have been rounded to the nearest whole number. Again, we wish to summarize these data in a way which makes clear their important features. One way in which we can classify these data is to draw a stem and leaf diagram. We use the tens and hundreds digits of the figures to form the stems, and the units digits to form the leaves of the diagram. The result is shown here. A diagram like this may help us to see where the main part of the claim amount distribution actually lies. Alternatively, we can draw a line plot of the data. This involves drawing a horizontal line with crosses marked in the appropriate place for each claim amount. If we have several identical claim amounts, we usually place additional crosses above the line, as shown. Although we have placed our crosses slightly above the line, we could place them on the line instead. However, we need to ensure that the resulting diagram is clear and easy to read. You may see a line plot drawn with the vertical axis more compacted, so that the crosses are closer together in the vertical plane. Data samples usually contain more than 10 values. How can we summarize data for samples containing larger numbers of values? Let us now suppose that the values we had before are actually part of a larger sample of claim amounts. Here is the full sample of 40 claim amounts. For larger data samples, there are other ways in which we can summarize the data. We start by constructing a frequency distribution for the data. To do this, we need to divide the data up into groups. We have chosen groups with a class width of 100, except for the last group, which has a class width of 400. If we do this, we obtain the figures shown in the table here. Of course, this is not the only way of grouping the data. We could use classes with a width of 50 or 200 units rather than the 100 units we have used here. There are no hard and fast rules for this, but in general we want to choose a class width which gives us enough detail about the distribution of the figures without giving so much that the overall shape of the distribution is obscured. The last class here has a width of 400 in order to group together the more widely spread data items. We now use these data to construct a histogram. In order to do this, we need the frequency densities. The frequency densities are obtained by dividing the frequency in the original table by the width of the corresponding class. This gives us the table shown here. Note that for the last class we have divided the frequency by 400 rather than by 100. We now draw a graph using the width of each group as the base of each rectangle and the frequency density as the height. This gives us the figure shown here. This is called a histogram of the data. Provided that we choose suitable class width, a histogram usually gives us a good picture of the shape of the distribution. Here we see that most of the claims are for amounts of between 200 and 400, and that the distribution has a peak somewhere in the middle. Another way to present these data is to draw a cumulative frequency table and a cumulative frequency curve. Let's see how we might do this. We start by finding the cumulative frequencies and putting them in a table. We want to find the numbers of claim amounts which are less than or equal to 100, less than or equal to 200, less than or equal to 300, and so on. This gives us the table of values shown here. We now plot these cumulative frequencies on a diagram and join up the points with a series of straight lines. This gives us the cumulative frequency curve. Sometimes a smooth curve is drawn between the points rather than a series of straight lines. From this diagram we can find the median or middle value of the distribution. We do this by drawing a line across from halfway up the vertical axis and then reading across and down. If we do this here, we obtain a value of about 290. This is one of the measures of central tendency we shall come across during this chapter. We can also find the sample quartiles of the distribution. The lower quartile is the sample value which lies 1/4 of the way along the distribution. We find it by drawing a line across from 1/4 of the way up the distribution and then measuring where this line cuts the curve we have drawn. If we do this here, we get a lower quartile of about 225. Similarly, the upper quartile is the point 3/4 of the way along the distribution. If we draw a line across from 3/4 of the way up the distribution and see where this line cuts the cumulative frequency curve, we obtain a value of about 420. This is the upper quartile of the distribution. The interquartile range is the difference between these two figures. It is one measure of the extent to which the sample values are spread out. Here we get an interquartile range of 420 minus 225, which is 195. This figure is our estimate of the range occupied by the central 50% of the distribution. Finally, we can draw a box plot for the data. This summarizes information about the range of values and the median and the interquartile range in a single diagram. It looks like this. The central box runs from the lower quartile on the left to the upper quartile on the right. The median is marked as a line in the middle of the box. The line extends from the smallest sample value to the largest value. Here is a summary of what we have covered in this unit.